Today is January 15th, 2025, with Mr. Touradj Ebrahimi. Thank you very much, Mr. Ebrahimi, to be with us today. You're well known as one of the key leaders of JPEG, a norm that the whole world uses today with pictures, JPEG, and then today with a moving picture, MPEG. So you're one of these key persons that develop and continue to develop that norm. But first of all, let's go back into history, digital history. At what moment did we start to conceive that a picture could be transformed into a digital picture? So when is really the origin?
The origins of imaging goes really very far back. In fact, it predates the photography, as we call it, that was invented end of 18th century using chemicals. Now, after a few decades, when the electricity and electronics was invented, people started to wonder if there is a way to get rid of the chemicals when you create photographies and use just digital signals to do that. So the first generation of the pictures that were not anymore based on chemicals, but more electronic, dates back to 60s and 70s. But they were not yet digital. They were still waves, electricity, basically, that was leaving traces. And the amplitude of the intensity of the electric signal was being correlated with the intensity of the color or the shade of how dark or how bright the parts of the image should be.
Did we talk about pixels yet?
No, this absolutely predates the digitization and the notion of pixels. Typically, pictures and video were scanning a surface of a sensor, and you were talking about lines, and every line had basically continuity, and all the information on every line of a picture or a frame of a video was corresponding to whatever the sensors was seeing, and it was translated to electric signals. Later on, when people discovered that computers are particularly well suited to process multimedia information, a next wave came. And people said, okay, now the signal is not anymore chemical, it's electric, and it can be translated into images. Is there a way we can feed it into a computer? And since computers speak a binary language, 0 and 1, we had to go and transform again these electric signals that were continuous into what we call digital. And this is where the notion of pixel appeared. You had to sample the surface into points that correspond to local intensities, and these are called pixels. And the value of the pixels were also digitized into a number of bits that represented, again, similar to the electric signals that I told you, into either color intensity or how dark or how bright is the shade of that pixel.
And at which year was it possible to visualize a picture on a screen?
Oh, well, I don't think that you could really say there was a year where this happened, but around 50s and 60s, people started to capture and display visual information It wasn't necessarily only pictures, it was also video, using electric signals. And for a very, very long time, the world of imaging was analog. It was not digital. It was not something that was particularly interesting for computers. So during 50s, during 60s, and even part of 70s, the world of imaging was analog. And this is one of the reasons also the television system that we consumed around the world, they were not digital. They were analog. NTSC United States, PAL or SECAM in Europe, these are television systems that were electric, but they were not digital.
And so gradually it moved into a real digital picture. How did this evolution happen?
Yeah, so one of the first drivers of the digitization was because computers were cheaper and they could do far more than the TV and photographic equipment that were analog but electric could do. So the pressure was high to represent images in a form that could be consumed by computers. That's where digitization and pixel started. And in the beginning, of course, it was not very competitive, if I can say, with the analog world. So the very first digital pictures that were produced were of lower quality, actually, than their chemical counterparts or the electric analog counterparts. But then, of course, as often, technology progresses, and at some point, around 80s, the crossover happened. And the quality and the appeal of the digital pictures started to surpass that of either chemical or analog, electric analog pictures.
And so what really came into what is known today as JPEG, how and when do you consider that this was really the origin of that let's say standardization, the origin?
So it took a while, actually, about 2 decades. I told you 80s. All the 80s and a good part of even beginning of 90s was devoted to optimizing systems. Because when you digitize a picture, it's good because you can feed it into computers, but then you want the whole world benefit from that. And this means that almost everybody should have equipments that can understand and process digital images. People don't go and buy these equipments if they cost as expensive as a car. So you have to reduce the cost. How do you reduce the cost? One way to reduce the cost is to reduce the resources that are needed in order to handle the digital information in form of images. So in the beginning, one of the biggest challenges that the world faced was that the digital pixels corresponding to a good quality picture were representing a volume of information that required a lot of resources. And if you had to move and send a digital picture from one place to another one through the channels, communication channels and transmission channels that were available, you had to spend a lot of effort and use a lot of resources. This is where the world started to say, okay, we have to really resolve this problem and reduce the volume of this information so that it becomes reasonable in terms of resources that are that are needed. And this is the start of what people called compression of information.
And this was a group that gathered three partners, apparently, in the beginning. And this group created what was known as Joint Photographic Expert Group, JPEG. You were part of the beginning of this experts group. What was the, first of all, who were the partners and how did it happen at first?
Yeah. So let me take back first and tell you a little bit how the researchers and professionals who were working on compression even decided to work together, because compression is something that you could imagine one or two researchers in one company they can do. And in fact, this was the case in the beginning of the interest around compression. A lot of universities in their research labs, but also a lot of companies in their research labs, they started to come up with methods to compress. And of course, some were maybe slightly better than some others, some were much better, but they were different from each other. But then there was a second problem that was identified. If everybody, they used their method, their language to represent pictures in digital form, you cannot have communication, because then you don't know when you receive a picture which language was used, which syntax was used, which algorithm was used to do that. So these people were really almost literally forced to work together and come up with a common language, a common syntax, and a common algorithm to compress images and then to do the opposite, to uncompress it in order to visualize these images. Now, around the world, this problem of having something common and agreeing on some common was happening in what is known as standardization bodies or standardization committees. And Switzerland is lucky because three of the major standardization committees, organizations that take care of standardization of communication, for example, are in Geneva. These are ITU, IEC, and ISO. A group of researchers and professionals from companies, they decided to work together in the framework of these standardization committees. They could have taken one, but they decided, in order to really make sure and ensure that it will be used worldwide and there will be a single algorithm, a single language, a single syntax, that they really do it in the context of the major standardization bodies together. And that created the JPEG group that you mentioned. And the J in JPEG that you mentioned, Joint Photographic Experts Group, the J refers to this joint nature of several standardization bodies working together and coming up with a single solution that can be used anywhere in the world without creating any confusion.
Who were these three major partners of this group?
The three major standardization that really gave birth to JPEG and supervised the work and published the standard are ITU, International Telecommunication Union, which is part of United Nations and is based in Geneva. There is the ISO, International Organization for Standards, and ISO, by the way, that I call ISO, is not the acronym. It's the word iso in Greek, which means equal, and the IEC, International Electrotechnic Committee. Each of these standardization organizations, and all three are in Geneva, they have as objective to create standards in different areas. The communication channels, how physically, for example, a plug should look like, and even what should be the format of the emails that you exchange. So a lot of technological tools that we use, either physically or algorithmically, they need to be interoperable. And these are the organizations that decide through a process that is very well defined how to reach agreement, how to reach consensus. It was really very natural for researchers who were working on compression of images and later on of audio and video to basically go and do, in the context of these standardization bodies, the standardization, because they had a process in place, they had credibility, and they had the everything that it takes to make this successful.
When did they decide to be together to define this norm? Approximately which year?
The work started, so this desire of working together started around 85, 86. So this is where really people got together, and especially a gentleman who has now passed away, Hiroshi Yasuda, who was working at that time at NTT Docomo in Japan. He gathered a lot of researchers and a lot of professionals around the world, and created some sort of association in order to exchange information. So this took a while. And at some point, the group called itself Picture Expert Group, so PEG. And then later on, around 86, 87, PEG became JPEG because they decided, as I said, to create this common language in the context of not one, but three organizations that take care of standards jointly.
And when did you personally appear in this world of JPEG?
So although I'm old now, the history that I just told you is even older than me. I was in 1989 doing research at EPFL as a PhD student in compression.
EPFL being the International Institute of Technology.
EPFL is the Swiss Federal Institute of Technology in Lausanne. And I was doing my PhD, the research toward my PhD doctoral degree at EPFL in compression. This is how I became aware of the existence of this group that had just become JPEG. And I started to follow their activities and interact with their members around 90. Then later on, in 1992, when I finished my PhD, I became even an official member of this group, and since then I've been evolving in that group until today, and probably for a while still.
Now, JPEG is evolving, and of course it's a result of a lot of research, as you mentioned. But there was a question of patents that was involved. In other words, companies, and not only academic institutes, worked on them and tried to, let's say, make profit of it. How did it happen? I will mention some companies like Fergent, I believe, claimed that they were really the fathers of this invention.
Yeah, so this is a good question. Let me answer to each part of your question a little bit separately because it's made of several questions. One is, can you call one individual or one company as the main driver or the father of JPEG? The answer is no. Unfortunately, the system that is used in a compression of JPEG is so complex that even for a company, no matter how large, it was not enough, it was not possible to really master all the aspects, all the technologies involved. So that's why, in fact, it made sense to bring in around the table many players, many experts, each maybe with their strengths in some aspects that complement each other. Now, when the group was created, it had two, at that time, very revolutionary visions that didn't exist at all before that, because this was really the first time people were really attempting to make a standard for multimedia information. Number one revolution was that instead of creating standards that would help companies to make products and services and optimizing the standards for the benefit of companies, the group decided to maximize the benefit of users. And the second, probably related, bold decision was that whatever this standard will become, it should be freely accessible to everybody. So combination of coming up and optimizing the system for the good of users of the technology and not the companies that they create them, and having it open and free were at that time very revolutionary. And let me be very concrete and give you really examples of each of them. When you have a picture and you want to compress it, if you are a company, for example, that sells infrastructure or has infrastructures, they would use the parameter of how should be the size of the image as the driver of compression. So logically, if you are Facebook or Twitter of the world, you have limited resources in terms of disk space, and you can say, oh, I'm not going to let users who use my infrastructure each have pictures that are larger than, let's say, 1 megabyte in size. So you could have said, and the algorithm could have been designed to have a parameter that says compress this image at 1 megabyte or 2 megabyte or whatever value you want. That's not how JPEG was designed. JPEG was designed based on a parameter that was saying what should be the quality. Quality is something that is very important for the end users, for the people. If your parameter is compress this image so that the quality is very high, even excellent, or average, or maybe below average, will give the end user the knowledge of what is really the quality of this JPEG. And that's why JPEG committee designed this algorithm and in a way that the parameter that was really interesting for the end user, which is the quality, was the driver, was the decision maker of how the algorithm should be operating. If it were for companies, it would have been maybe another parameter, like what is the size? which is not the case of JPEG. In terms of openness and freely accessibility of the standard, there was a decision, again, that all companies or researchers, they can, of course, have patents. They can protect their technology. But if their technology is used in the context of JPEG standard, then they have to give a license freely to everybody.
In order to understand what it means to say we have a patent due to the fact that there is precisely this open source available through JPEG, what kind of patent can it be possible to sell or to defend?
Yeah, so anything that you do that is original, that is not easily done, you can protect intellectually, right? There are two main ways. Either you copyright, in this case, there is no notion of copyright, but you could also have patents. Patents basically say, I have an idea about a component and I want to protect it. I want to protect it through a patent because I put resources, I put time to create this. And you don't want then to have a black and white situation by saying, oh, it's free for the whole world, because then maybe next time nobody gives you the resources, especially if you are working for a company, because they say it's lost. Even our competitors will benefit from it. Or you would say, okay, I have a patent. I will patent. I will restrict this use because people have to come and ask me authorization. And maybe I give them a license. I tell them you can use it if you pay me this or that much in one shot or in a recursive way. JPEG committee knew that the technologies that are needed, they will have intellectual property, they will have patents. So it didn't say use technology that don't have patent, because usually technologies that don't have patent, they are not very good technologies, because if they were good, somebody would have patented it. The creators would have patented it. So instead of saying it doesn't have patents, JPEG committee says you could have patents, there's no problem, but as long as is this component, this technology is used for the purpose of compression in JPEG, you should give licenses for free. But if your competitor takes that component and uses it in another system, then of course you could tell them, no, you cannot use it, or you have to pay me some license to do it.
Yeah, but concretely, what patent can add to this available platform that is JPEG? What can you give me an example, concrete example of what could be added through a patent?
Yeah, so patents is just protection, right? So JPEG algorithm is just a bunch of processes and algorithms that are originally designed, and they have been put together, integrated together, also in an original way. In the best of the world, it would be great if there are absolutely no patents, of course. But as I said, if you cannot impose good technologies, usually are invented inside research labs, also of companies. Companies, they have to make a living, so they have to have a return on investment. So they need to patent these technologies. Often also, and more so, in universities, universities need return on their investment, or just for the purpose of having control of who will use what they had invented, they also patent. So universities like mine, but almost any university that respects itself and creates value, they patent the original technologies that they create. But patenting doesn't mean necessarily that you forbid. You could patent something and you then give it freely. So you give a free license. You could even give free license for any purpose, anywhere, forever. You can do that. But the fact of patenting is always a good thing, because if you don't patent, maybe somebody else is going to patent what you've invented. So sometimes it's even for the purpose of defensive. You have invented something, you patent it because you don't want somebody else to come and patent that technology for you. It gives you control. That's why patents exist. They do not really change the technology, but this is something that usually exists with any technology that has value. You want to have the ownership and the control of who uses or who doesn't use that technology, and you don't want to give that control to somebody else either. You want to keep it. That's why you patent it.
Okay, but with a platform such as JPEG, what can be concretely added through a patent? In other words, if a company wants to make a profit out of its research, what concretely can this company give me an example of what could be added by a position to the open source that now exists?
Yeah, so there are two different things. One is open source. Open source means that the code, the program that you have that implements in software, for example, and often it's software, your algorithm is openly accessible. This doesn't mean that it's free. So there is a difference between open source and patented technology. You could have patented technology in open source. So open source just says it's open, because the alternative would have been, I come up with an algorithm and I keep it a secret. I don't let anybody know about that. So one of the decisions of JPEG committee when it started was we don't want to have anything that is not open, because it should be standardized. Anybody should know what happened. Anybody should be able to implement it. And as I said, so not only it should be openly accessible, like open source, but at the same time, it should also be without any licensing fees. So in the case of JPEG, the decision was that if a company has invested resources, time, etc., money, basically, in creating a technology, of course, it's their right to control that technology. But if they want to see that technology inside JPEG standard, they have to give a free license. That's how it started. But there are some other later technologies in JPEG, but also in MPEG, for coding of audio and video, where this is not the case. So there are standards. In fact, JPEG has a few of them, like JPEG XS, where these companies, they don't say we give it for free, but they give a minimal fee that is fair and reasonable. In English, there is a word for that. It's called FRAND, fair, reasonable, and non-discriminatory, meaning that you cannot say, oh, if you are from this or that company or that country, you cannot use it. This is not allowed. Everybody in the world, because these are international standards, so you cannot discriminate among who can use it or not. So patents complicate this situation, but it's part of what comes with the territory, as they say. Mm-hmm. They are unavoidable. If we create standards based on technologies that should be absolutely patent free, the surest way is to wait 20 years after the publication of the technology. And even if they had patents, after 20 years, it's known that all patents are then obsolete. So you can only impose rights on a patent for 20 years. So the surest way to make sure that a technology doesn't have patent is to wait 20 years after it's published. But then that makes it also probably very likely obsolete. So you don't want to have very old technology and create standards with. You want to have very, very recent technologies, and you have to come up with a way to coexist with this desire to patent technology in order to control. So you say you could have a patent, but if you want this to be part of the standard, preference, in JPEG at least, is you have to give a license that is free. And in some cases, some JPEG standards, some MPEG standards, you say, okay, you could have a return on your investment, but it should be reasonable, fair, and non-discriminatory.
So, JPEG being open, a company that wants to have profits, what kind of improvement could be concretely subject to an improvement of today's standardization? Could you give me an example of what an improvement made by a private company using this platform JPEG?
Yes, absolutely. So if you go back in the beginning of when JPEG 1, the first JPEG standard, was standardized, which is 1992, and you look at the implementation of that compression algorithm, and you compare it with the latest one that you have today, the latest implementation, you see that sometimes you can do twice, 3 times more compression for the same performance using the same resources. How is this possible? It's possible because on one hand, the standard has some parts that are flexible. So it leaves a little bit of a room for competition for people and researchers and companies that are smart, that can take advantage and create better implementations in terms of even additional algorithms. So you can bring in some original ideas into it and even patent it and even keep it because they are not necessary for the implementation. These are add-ons. And the second one is that as time goes, different architectures happen, hardware architecture, software architecture, and there are, we learn to implement things better and better and better. Even the same thing, we implement them better and better and better.
But whoever starts with this improvement and gives it has, as you said, has to license it, but give it publicly, free to the public.
Not necessarily. Most, they do that. Mm-hmm. So some of I can give you a very concrete example. Just a few months ago, in 2024, the company Google, and those who were behind it, they were based in Zurich, by the way, so not very far from us here. They took the original JPEG 1 algorithm and they tweaked it, but in a way that was still compatible with it. And they called it jpegli, like the Swiss German, they like to put Li at the end. And Google decided that they want to give it for free. So they are free. There are products that exist. Sometimes they call them super JPEG, sometimes they call them double JPEG, things like that. They use a little bit of this flexibility of the JPEG in order to compress pictures, but they only put it in their products. They don't even necessarily tell you what they have done. The pictures that you generate, any decoder in the world, any product in the world will be able still to open it and display it. But the way it has been created is that of a specific company, that they have put it in their products, and you don't even necessarily know what they have done. So both have happened, and they exist in JPEG. There are some who improve the JPEG algorithm, and they decide it's better for it to be free, because Google doesn't have any interest to make money through the licenses that they give to their competitors. They have better ways, and it is in their interest to see more and more people use pictures of higher and higher quality or more and more compact.
So JPEG L that just came out.
JPEGli.
JPEGli, yeah, with the letter L, right?
No, Li, JPEGli, like Hensley.
Oh, I see.
So it's as you know, in Swiss German they like to put Li at the end of some words to make it little, like Hansley or yeah. That's a little bit of a.
But isn't there a JPEG L as well?
There is no JPEG L, but there is something called JPEG LS, which is the lossless JPEG.
Which is different from.
Which is different from JPEGli.
Okay,
yeah.
We'll hear about that. But with the JPEGli, what is the specification of this norm?
Yeah. So one of the things that the JPEG standard doesn't tell you how to do is how to manage the amount of distortion that is created when you do compression. So basically, designers of encoders can decide to do it the way they want. And in the case of JPEGli, they have a way that is even publicly available that makes the compromise between amount of compression and the visual quality of the distortions in a better way than alternatives that exist.
Means less heavy?
Meaning it impacts, so they use the knowledge of human visual system, because human visual system has some limitations. So you try to push the distortion into areas that human visual system sees less or is bothered less with it. That's what they do. Now, of course, this was not known even to Google even 5 years ago. So they did tests and trials and errors, and they came up with a new recipe that can create JPEGs that can be still decoded by any JPEG decoder, even the one that was created 40 years ago, and still be seen. But either the quality of the picture will be higher, or for the same quality, the picture is smaller.
How would you define for a public that is like me, not knowledgeable about the compression system, how would you define the principles that allow a non-compressed picture, original picture, like in TIFF or in RAW, come into a JPEG? What is made technically so that it becomes finally JPEG?
Yeah, that's a good question. Not only in JPEG, but every compression, image compression algorithm relies on two approaches in order to compact the volume of information required to represent it. The first one people refer to as redundancy reduction. What does it mean? It means that, for example, if you have a picture of a person in front of a wall behind a person, and the wall is, let's say, of the same color, it's not very efficient to say the value of the pixel is on the wall is white, then the next one is also white, the next one is white, the next one is white. There is a redundancy there. You don't need to all the time repeat. This pixel is white, the next one is white. So what you do is that you say pixels from this point to that point, this collection of pixels, they are all white. And that's the value that corresponds to that white. This is called redundancy reduction. So you can already reduce a lot the amount of information. And on top of it is lossless, meaning that numerically you compress, you reduce the volume, but numerically you don't introduce absolutely any distortion, which is great. But we know that redundancy reduction, researchers have found, it can only go so far. So you cannot really go to very large amount of compression like 10, 20, 30 in terms of amount of compression that you can apply. So there is a second approach that is also very, very popular called, this time, relevancy reduction. Meaning that when you look at a picture, for example, if a person is looking at a tree with a lot of leaves, etc., often a given pixel on the tree, because of the texture that is there, if you change it slightly, nobody will see it. Why? Because that's how human visual system works. When you are in what is called high frequency, meaning very, very noisy areas, that the leaves of a tree, for example, are very noisy. If you go and change the value of 1 pixel only, no human will see it. So there are a lot of tools that reduce also relevancy. Of course, these tools, they create distortion. So numerically, you don't have the same image anymore. But if you look at the image, you don't see. A human will not see the difference. And JPEG is basically have a number of tools in its system that reduce redundancy, and a number of tools and components in it that reduce relevancy. Now, the relevancy is not only the example of the tree and the pixels on a tree that I gave you. The same is true also for example, the color. There are some colors we have much more difficulty seeing. So if we change a little bit, if there is a little bit of distortion, no human can see, because our visual system has been designed in a way that we cannot perceive all colors with equal sensitivity. So if you come up with ways to compress, but then the distortion you create are in areas where a human has difficulties or even maybe doesn't see at all, although it is a lossy compression of an image, numerically speaking, it is perceptually lossless because a human cannot make a difference between something that has been compressed and something that has not been compressed.
So, in all these last years, there have been evolutions, or let's say constant evolutions since then. And today, JPEG has different names. There is JPEG 2000, for instance. What is the difference between the JPEG 1 originally and today with new forms? I will name JPEG 2000, JPEG XS, extra speed, also JPEG extra long term, XL. Could you give me information about these various norms of JPEG today?
Yeah, that's another very good question. It all goes back to what was the vision of the original standardization committee I told you about in around 86, 87. You would be surprised to find out that the trigger that created the creation of this group, that now it's called JPEG, was an application that today does not even exist. And you could even argue maybe it never existed. Let me explain what it was. When you start doing something, whenever you develop a technology, it's always good to have an application in mind. And the application that seemed to be very interesting for all these people was teletext. So you probably remember the analog days of the television, where at some point it was possible to insert some text in your television signal, and then you could, with your remote control, for example, look at advertisements, have some information, etc.
Forecast.
Yes, it was part of the broadcasting. That was most broadcasters in the world were inserting this kind of information. Even the program of the TV, you could watch it. You could access it this way. One of the problems that this system, the teletext system, had was that you could not produce images. So if every time you had to create some illustrations, it was by putting together some graphic looking things that didn't really give you a very appealing visual appearance. So the first application that you could call these days killer application that drove the first attempts into compression that became JPEG was teletext. So the design of the system was done by taking not only but especially teletext and creating a format so that pictures can be of good quality, can be shown also in teletext. History shows that this is not how JPEG became successful. JPEG became successful because the standard was there, and it was a question of pure luck. In 1992, the standard was published, and a couple of years later, the World Wide Web in 1994 became widespread. And again, somewhere not very far from Geneva in CERN, people said, oh, the World Wide Web not only needs text, it also needs pictures. And then they look around and they say, oh, there is this JPEG format that is there, and they adopt it. So what really triggered the success of JPEG was another application. In parallel, more or less, in the beginning of 90s, digital photography started to also appear. And then, of course, the manufacturers of digital cameras, they needed a format so that they can exchange, right? So you cannot, for example, buy a Canon digital camera, and then if 3 years later you want to switch to Sony, then all your pictures are obsolete. So there had to be a common format. Again, that was JPEG, and this started to spread everywhere, and that was the reason JPEG, the first JPEG standard that everybody knows, became very successful. But then these applications started to also identify some of the shortcomings of JPEG 1. For example, there was a need in medical imaging to have at least part of the picture lossless numerically, not only perceptually, because there was no assurance that if you really create distortions due to compression, a doctor who would look at these images could not then make a false diagnosis and maybe injure or even kill somebody because there is misdiagnosis. So JPEG 2000 did not find, complemented JPEG 1 in areas where JPEG 1 didn't find applications, because those who had these applications, they found JPEG 1 wasn't very suitable. So JPEG 2000 basically was designed because also technology had moved forward, and people needed, for example, mobile phones started to appear. Nobody had ever the idea that maybe pictures can be taken with a mobile phone and sent through the air somewhere else. So JPEG 1 didn't have the sufficient set of tools for that, so these tools were added, and they created JPEG 2000. The digital cinema is, for example, using JPEG 2000. Later on, it became clear that complexity and resources in some applications are very, very important. Latency of how long it takes to compress or decompress an image becomes very, very important. For example, in self-driving cars. Self-driving cars that have cameras around them in order to see obstacles around them, if you can gain in terms of latency of the system, what is happening and what the system that controls the car can do in terms of reaction, if you can speed up the latency of the system, you can save lives. Because even for a car that runs at 120 kilometers per hour, you could have a difference between life and death if you gain 0.1 second.
Is this what we call today the JPEG extra speed? Is that it?
Yes, that's it. So the JPEG XS was caused, and one of the main drivers behind JPEG XS was that you need very low latency, and neither JPEG 1 nor JPEG 2000 had the tools, had the necessary in order to reduce the amount of information that you need in a way that the latency will be very, very low. JPEG XL, L stands actually for not extra large, but extra long. And this was the long term when it started a few years ago. It was the extra long vision of JPEG standard. So JPEG 2000 and JPEG XS did not replace JPEG 1. And JPEG 1 is today the most popular format that is used, despite the fact that there are new standards. They could never unseat JPEG. JPEG XL has the ambition of replacing JPEG 1. And it has a number of tools that are particularly of interest to future applications, but also to past applications. So one of the interesting things is that if you go from a JPEG 1 format to a JPEG 2000, or from a JPEG 1 format to a JPEG XS format, because these are all lossy, it's very, very hard to manage the how to control the amount of loss when you do conversion. In JPEG XL, the transcoding is lossless numerically, meaning that this problem does not even exist.
How come?
Well, it's the algorithm that allows that. The design of the algorithm behind JPEG XL is in such a way that it can emulate, but in better, while using better tools, what JPEG 1 components were. So basically, each component that was designed 35 years ago was revisited, and a better version replaced it, keeping in mind that complexity is still very important. So in fact, today, JPEG XL is starting to appear and replacing maybe one day the JPEG 1 standard. If you buy one of the latest iPhones, iPhone 16 Pro or Pro Max, or one of the latest Samsung mobile phones, they use actually JPEG XL. They still use JPEG, but they also use JPEG XL because JPEG XL is just better. You can compress better. The quality, even if it is compressed better, is even better, and the resources are comparable to the resources of JPEG 1 that was designed 30-something years ago, which is natural, right? After 30 years, of course, people and researchers have thought about new ways of doing things. So this is what JPEG XL is. So there are other attempts that in future there will be, and there are work around JPEG, new JPEG standards. Every time you look at what are the shortcomings of the previous generations for typical applications that did not use them, and you ask yourself why, or you ask yourself, is there a better way to serve this application by another format? And then If there is, the answer is yes, then you come up with a new standard.
There are other norms in photography, for instance, TIFF or RAW, that use, of course, a lot of more space. Now, these norms, how were they defined in relation to JPEG, historically speaking?
Yeah, so that's another good question. So TIFF is not a compression standard. So TIFF typically does not do anything, any attempt to reduce the size of the picture. So what is coming out of the sensor is packed into a format called TIFF. So every pixel is there. There is a repetition of the value of every pixel, etc.
Who developed TIFF, by the way?
The TIFF is not an international standard per se. It's a format that was defined by some people who got together, the same way some people got together and created GIF, GIF. So these are not standards in the sense of international standards by ITU, IEC, and ISO, and there are a number of them, and TIFF is one of those.
But it's open source as well.
They are also open source, yes. Not only they are open source, for example, typically TIFF is open source because it's also very, very simple, right? So it doesn't really do anything else than just wrapping the value of pixels with a header that says it's uncompressed.
And who developed it?
Again, there, the same way for JPEG, you cannot say who, one person.
No.
A group of people got together and
which
they
group?
created it.
Which group of people?
It was an ad hoc group, so it's a little bit like the open source community, right? A group of people, they get together, they do this, then some go to retirement, new people come, some lose interest, they leave, etc. So it's a community that is more like an open source community that comes up with some open source for some purpose. So you cannot really put your finger on one or a few people even by saying, oh, these are the ones. Of course, that really created it.
Of course, but precisely what is interesting for us is to see people behind technology. And today, you're known for, some people call you Mr. JPEG. So in other words, you are really someone who is personally connected with JPEG. Now, let me ask you, what has been your role in JPEG since you arrived into this technology, and when?
The reason I'm sometimes maybe wrongly referred to as Mr. JPEG is because I'm what you would call the conductor of the orchestra that is the JPEG committee. Every standardization committee like JPEG needs some sort of coordinator, chairman. And this role since 11 years I have been assuming.
But before that, you were already involved in it.
Yes.
So let me ask you, when did you really put your foot into this world of JPEG?
So I really came to know about JPEG when I started my PhD at Swiss Federal Institute of Technology, EPFL, in 1989. In fact, I started in January 1989, so it's really exactly 4 years ago. And at that time, the topic of my PhD that was given to me by my supervisor at EPFL, Professor Murat Kunt, was compression of images. It was a very, very cutting-edge topic. And the only forum, beside other researchers in isolation doing similar things, was the JPEG committee. So JPEG committee existed for 2-3 years. When I found out about it in 1989, it was really right in the beginning. The standard was designed and published 3 years later, so I could follow, but as a junior, that activity. But later on, when I did my PhD in 1992, I became more mature because I had more experience, and then I became a very active member of the JPEG committee. I started to have different roles to coordinate some of the activities, and then about a decade later, in 2014, I was elected the chairman of the JPEG Standardization Committee.
What motivated you to enter this world? What really was for you let's say the main reason to be involved in it?
It's a good question. You could say on one part it was because the opportunity was there, right? So sometimes you have to see what opportunities are in front of you. So a little bit of it was that. I was lucky enough to be in a place where I was allowed and I was able to connect to the world of JPEG. But on the other hand, one of the reasons I really also was very interested in getting to standardization was that I've always been fascinated by how people communicate. People with different languages, with different cultures, and different history, and different experiences. And often, a lot of misunderstanding in this world where we live is because people miscommunicate or misunderstand each other. One of the sources of misunderstanding is the language barrier. And images are wonderful means of communication between any two human beings that is pretty much agnostic to culture and language and a lot of things that makes verbal communication or written communication more difficult. So that's part of it also. So it's a combination between what was the opportunities that were open to me, but then of course some of these opportunities I had a little bit of a better affinity with than others, and it happens JPEG really was on top of the list, and I ended up really making in my entire career in there.
In these previous, these first years, like 1990, 92, when you really worked with that, what was really your idea of what could be made, and what were your hopes at that time?
So let's not forget I was very junior. So part of that is that I was a little bit naive too. So for me, my vision of the world was much more simple, or simplistic, I should say, than what I then discovered it was. For me, smartest ideas, smartest system would always win. I discovered it's not that simple. You could have the smartest ideas, the smartest system. If you don't communicate them properly, you won't be. So in French, there is a saying, it says, le savoir-faire et le faire savoir, meaning that it's not enough to have the best ideas. If you cannot communicate properly these ideas to others, it's almost like not having these best ideas, because others do not know about it, or at least do not get it the way they should. I also learned through standardization, which was really a school of life for me, that there are also a lot of economic, and also national interests, and of course cultural, that are needed to be understood. So you need to put yourself in a situation where you understand not only what another expert who is involved in the standardization is telling you, but why they are telling you this. And try to understand their motivation so that maybe a compromise can be reached through another solution, which makes them also happy for whatever triggered the solution they come up with. Maybe there are alternative solutions that make them happy. So all these together, I think that they're very, very valuable. But in the beginning, I was very, very naive, and what triggered me was that I considered myself to be smart enough to be part of definition of a major revolution that was digitization of pictures. And I just went there because of the encouragement of my supervisor. And in the beginning, of course, I made many mistakes, including the ones that I told you that I know now more about, and maybe I do less these mistakes. But the truth is, every day I learn new things, and this is also another very, very interesting side product of being involved in standardization. You continuously learn because you meet new people, there are new countries who come, new applications appear, and I'm exposed, especially in the position that I have now, to amazing applications that maybe otherwise I would have not seen at such an early stage, because often you need standards when you have revolutionary products and services in mind, and I'm really in the forefront of knowing about these things that probably the world will see 3-5 years later.
And this revolution continues, and you are still part of it, particularly the still picture with JPEG has moved into the moving picture, MPEG, and this is a continuation of this. How did it progressively occur, this possibility to compress as well the video?
Yes, so that's also a very, very good question. Here, actually, the story of MPEG is much more clear because one of the members of the JPEG committee, an Italian with the name Leonardo Chiariglione, when he saw that the JPEG committee, and he was member of the JPEG committee, was standardizing the format, digital format that will be potentially used for applications where images will happen, had the idea by saying, okay, but then what next? And it was natural that moving pictures were going to be the next. So he talked to Hiroshi Yasuda, that I told you was the person who really for the first time gathered everybody. He talked to him and he told him, what about also creating next to JPEG, MPEG, by replacing the J by M, being a sister committee. But the goal of the committee will be, of course, to use some of the finding of JPEG for still pictures, wherever possible, use them. But then you need new technologies. Let's come up with new technologies and create new formats for video. Interestingly, so when the work started, very, very quickly, it became clear that you needed 2 more standards. Often video doesn't come along, except in video surveillance. Often video has also audio with it. So the MPEG although it says moving picture, also has amazing standards and started to standardize audio formats, compression of audio. MP3, the famous MP3 that is used in music nowadays, is actually one of the standards that it created. And shortly after, again, it became clear that standardizing only video formats and audio format wasn't enough. You have to have efficient ways to mix them. So also what is called an MPEG systems standard was created to mix, to multiplex audio and video in the proper way. So this is really how MPEG started. And I also, and I still continue to be involved in MPEG standardization. In fact, I've been almost, historically speaking, as much involved in JPEG than MPEG. I'm probably the oldest MPEG member who is not retired yet. It's also another very, very fascinating world, and with a lot of applications that we see on a daily basis.
People get confused sometimes with the letters after the documents, such as .mov or .mpeg, .mp3, and so on. How could you define, let's say the document or itself and the name next to it? Let's take the example of move, for instance, because you can use obviously MPEG with the final move at the end of the document.
Yeah. So when you have a file in your computer that is some name, dot, and then often 3 letters, they represent what is the format, which is, of course, if there is compression, which compression, but how it has been wrapped. These letters, they often refer to what is the wrapping, how it has been wrapped into a file, but sometimes also which technology was used for compression, if there is compression. For JPEG, the first product of JPEG that was published in '92 is .jpg, which is a shorthand for JPEG. For JPEG 2000, it's .jp2. For JPEG XL, you mentioned, it's .jxl. For MPEG, there are a number, but the one that is really the most, I would say, widely used are .mp3, which is any file that has an MP3 MPEG audio layer 3 compressed audio in it, and .mp4, which is basically almost every format that MPEG Standardization Committee has created that is wrapped into this file format.
How come is it possible? Sorry, how come is it possible to choose from your file to say, for instance, I want to name it .move or .mp4, and it works on both cases?
Mm-hmm. So you don't usually choose, right? So you choose the dot something is usually a consequence of the engine that you have used to create the content. So often, if you go and just change the name of a file from, let's say, .mp3 to .mp4, then your decoder won't be able to really read it.
But from move to MP4, it's usually no problem.
That's correct. Yeah. Now, .move, .gif, GIF, .png, etc. These are formats that are not. These are file formats that are not all created neither by JPEG or or MPEG. Typically, .png is a format that does a little bit of a compression, but historically was developed by another committee in ISO that is called SC24. That is about computer graphics. So computer graphics has some particularities that in the beginning, when a format was needed, was developed by another group, and that group is part of ISO, not part of ITU, but part of ISO, and they maintain it. Even today, they maintain it. .gif was a proprietary format, and it is being maintained now again by one of those unknown groups, open groups that nobody really knows who are, and people come and go. So it's one of these open source communities that maintain it. And .move is also a similar. So it's not an ISO or IEC or ITU format. It's a format that again is maintained by the open source community.
PNG is used, for instance, regularly when you capture a picture on your screen.
Yes.
So what is the advantage of maintaining PNG rather than, for instance, using JPEG when you capture a picture on your screen?
Yeah. So if you look at the latest JPEG standards like JPEG XL, there is no advantage of using PNG, it's true. But for historical reasons, and that's one of the strengths of having standards, international standards under ISO, IEC, or ITU, is that beyond the creation of and publication of a format, you need to maintain it. If suddenly something happens, and because of some natural or human-induced reasons, we lose a lot of our history. And if some of it can be found 1,000 years from now, 500 years from now, it is always good if there is a trace of what was the algorithm that was used to create that content. That's why the standards, international standards, also play a very important role. So maintenance. So it's true that .png became pretty much obsolete maybe almost 20 years ago. But you still have to maintain it. There should be a place where you keep things. There should be a number of people who make sure that when operating systems change, when new operating systems happen, when new architectures for computer platform appear, these formats can also still be implemented in them. And that's very important.
For archives, I can understand that, but why maintain PNG when JPEG is used for practically everything else when we take a picture with our cameras, with our iPhones, etc.?
Well, there will be always people who will still use .png. And you need to have these formats around. In fact, PNG is I think, beside after JPEG, the largest used. Now it's true. Maybe JPEG is like 80% of all the picture formats, but then after that probably is PNG.
Yeah,
so
but I mean,
probably 10-20% of the pictures that are created and being exchanged are in PNG.
But my question is, how useful is it to maintain PNG rather than having just one standard, which might be easier?
Of course. So the dream would be that there is only one standard. Unfortunately, there is no government in the world that can impose that to everybody, right? So it's people are free. And there are, even as we talk, I'm sure there are people who create content because they I don't know, they record the screen of their computer, or they do. There are a lot of products still around that store the output that is in form of images in PNG.
But whether it's, let's say, the computers, let's take the PCs or the Mac, they all use PNG for capturing the pictures.
Yes.
How come? Since they also use they all use a JPEG. How come?
That's true, but you know, JPEG is lossy, right? So JPEG is lossy, and the best way to ensure that there is no, I would say, the second best choice is to use PNG. Although now with JPEG XL, you don't need to anymore, because JPEG XL has a lossless version that is more efficient and more or less as complex as PNG.
But PNG is heavier than JPEG. We know
in
that.
Volume, absolutely.
And so I still try to understand why is it still used.
Yes, so I don't know either. If it depended on me, of course, I would have encouraged everybody to look at more modern and more recent formats. But as long as there are people who still some people don't like to lose their habits. I think it's natural that these formats are also maintained as long as possible.
You are an actor in this series of evolutions and revolutions, should I say? And of course, one of them, major one, of course, is the artificial intelligence. You work in it. How do you see this evolution based on the evolution of the image itself? What role will IA play in the future, and what has it already started to play?
Yeah, so artificial intelligence, although it became in the radar of people only a couple of years ago with the creation of the service of ChatGPT, has been around for much longer. As you might know, the word artificial intelligence is something that exists since around 60s, and even before that, the notion existed. So artificial intelligence used to be called automata before. And if you go back historically, you could go even to the Greek philosophers who imagined the philosophy behind what is logic and what is thinking. So it really has roots that go millennia. But if we come back again more recently, the imaging community, since at least a decade, has been aware of the fact that artificial intelligence can revolutionize the world of imaging. Now, many people see that. It is actually a lot of face recognition systems. They use artificial intelligence nowadays. You could generate images by means of textual description. You can improve and denoise or increase the resolution of pictures nowadays using artificial intelligence. And the JPEG committee started, in fact, 7-8 years ago to look into how artificial intelligence as technology can impact the future of applications, and whether JPEG as a standardization committee should do something about it. And the answer is yes. And there are three things three projects that were initiated. One of them is almost finished, so I'm going to start with that. But there are two others that are also to different levels of development. The first one, we call it JPEG AI as artificial intelligence. So as I told you, the different generations of JPEG standards. They all use the latest technology for applications that might need them, either applications that they didn't use the previous generation or applications that are using previous generation but are looking for even better solutions. And artificial intelligence happen to be, some components based on artificial intelligence happen to be among some of the candidates. Now, concretely speaking, JPEG AI does a very, very good compression compared to, of course, JPEG 1, but even the very latest JPEG XL. So you can typically do 30% or more compression by keeping the same quality, which is very interesting. And it uses a new architecture that computers did not have when even JPEG XL was designed. And this is GPU instead of CPU, or NPU instead of CPU. CPU stands for Central Processing Unit. This is how even the first computers architecture were based on. More recently, because of computer graphics, graphic processing units became more popular, and they really bring a number of very, very interesting features. And there was a need for a standard for image coding that would take advantage of that. An NPU, a neural processing unit, is a GPU that runs on a autonomous system like a mobile phone. So a GPU on a mobile phone, usually you call it NPU, to show that it's not very power hungry, it's battery based. So JPEG AI is taking advantage of this type of architecture using a lot of innovations like deep neural network and training and machine learning in creating coding and compressing images, but also at the same time, because more and more pictures are being used by machines without any human in the loop. Think about a self-driving car. A self-driving car, the pictures that the cameras take from the road to let the car go where there's no obstacles, there's no human in the loop, right? So the decision is done by the machine that is in the car, that is often artificial intelligence. And when we talked about JPEG XS, we said latency is very important. So if you can come up, and this is why JPEG XS was defined, if you can come up with compression and decompression algorithm that have a very, very low latency in the order of milliseconds, 1,000th of seconds, or even microseconds, it's great. Because the time of decision is reduced between something that happens and something is decided. Now, if you can make this decision without even compressing, so applying artificial intelligence directly to the compressed content without even decompressing it, we take some resources and time, it's even better. And JPEG AI brings that. So JPEG AI, if I have to summarize, not only does very well for applications where there are humans in the loop, it does also very, very well for applications where no human is in the loop.
In order to understand it, let's take a compression, let's say from TIFF to JPEG, using the artificial intelligence. Does it mean that rather than doing the process and calculation of the compression, it directly decides decides where to go, or which let's say which pixels to use? Is that correct? This is the procedure is to avoid the calculation time.
Yeah. So let me tell you what artificial intelligence brings in JPEG compared to the previous generation of JPEG standards. The previous generation of JPEG standards, as I told you, they are all based on two approaches: redundancy reduction and relevancy reduction. These are a set of tools. They are designed based on models we know about human visual system, and they are mostly driven by the way, our knowledge of human visual systems. So a lot of, starting from JPEG 1 all the way to JPEG XL, and in between, everything, JPEG XS, JPEG 2000, etc., they used a lot of knowledge that we know from biology and physiological characteristics of human visual system. We took advantage of those properties in order to design these formats. And all these formats, although every new generation did better than the previous generation or brought something new, they were all based on the same thing. There was always a human in the loop, and everything was designed by taking advantage of the body of research that researchers in psychophysiology, for example, or in biology, and so on, did come up with, and then engineers took those models and created algorithms based on those models. Artificial intelligence is doing it in a completely drastically different way. It does it with learning. You know, when you take an infant, when an infant is born and comes out of the mother's womb, often the vision is not working that well. In fact, children, the first few weeks when they are born, infants, because in the womb it was dark and they couldn't see really anything, their vision is not developed. The first few weeks, they develop their vision. How do they do that? By observing the world around them. They receive examples. And through this learning, their artificial intelligence, which is this time natural, which is their neurons, they arrange themselves to understand what is going on and to make sense of what is coming from outside through their eyes to their brain. We are using exactly the same approach for JPEG AI. JPEG AI is doing relevancy reduction and redundancy reduction at the same time through a deep neural network that learns. So you give it hundreds of thousands, if not millions of images, and that's what JPEG committee did, by the way. JPEG created a very, very large number and collected a very, very large number of pictures of all sorts of content and trained an artificial intelligence system in order to maximize the compression by reducing both redundancy and relevancy at the same time. You cannot even separate them anymore.
But does it need, in order to be efficient, to be online? In other words, to have access to this large data? Or can an application, let's say, apply this knowledge?
So once you have done, so what I explained to you is how you train the neural network. Once you've done the neural network training, then you don't need these images anymore. So the artificial intelligence that is used in JPEG AI is a neural network that has a number of weights, and these weights are defined. And they were defined based on optimization that was through learning, but then you don't need this content, you don't need to learn anymore. The thing is there, and by the way, it's quite efficient in terms of complexity. So they're not now, about a couple of years ago, when JPEG AI was in development and we were in midterm of the development of JPEG AI, we could run compression and decompression of images on mobile phones already in real time 2 years ago. Now we are, of course, 2 generations even farther. So it's absolutely, there is no doubt that the JPEG AI algorithms for coding that are really far more efficient than the previous generations, but they are a completely different type of animals, are going to be efficiently deployable on even mobile phones, let alone servers and computers and things like that. So this is JPEG AI. But there are two more things that have caused JPEG committee to also come up with standards. One of them is not actually about coding. Artificial intelligence has created a situation where you can, in fact, create what is called deepfakes or generative AI, which is, if I summarize, is creating pictures by using artificial intelligence to either take existing picture and modify them in a way that it's undistinguishable from the reality, or even from what people call prompts, from textual description. So you can say, I want to have the picture of a lady with sunglasses, red hat, blonde, smiling and holding an ice cream in the hand. A picture gets created through the artificial intelligence, and the result is increasingly undistinguishable from pictures that would come out of a camera. So this creates a big problem. How can we know what is real, authentic, and what is generated and synthesized by artificial intelligence? And for that, JPEG has been working on a standard that is nearly finished now, called JPEG Trust. It's a standard that allows the people, so it will be hopefully deployed. So currently it's not deployed because it's not completely finished, but it is a matter of weeks before it's published. And once it is published, we are hoping that it will be deployed and can be used by those who use generative AI to create pictures, like ChatGPT and a number of servers that exist that allows that for consumers, and also even cameras.
We are in January 2025 when we speak, so that's very, very soon, you say?
Yes, so the standard will be published by ISO and IEC, because it's a joint standard. It belongs to JPEG. Early February 2025. So we are really weeks from that. So it's all the work is already done. So what is not done is that the administrator in ISO and IEC, they have not yet formatted and put it online so that people can download.
Can it give us a hope that with these new tools, there will be a possible identification of what a true picture originally is, and a let's say a made-up picture, a fake picture, is made?
So this is the attempt, right? So the goal of this standard is to help to facilitate identification of what is coming from a sensor and is authentic, like a camera, and what is manipulated, maybe for even good reasons. It doesn't mean always in a negative way. You could, for example, decide that you had a picture and there was a person on the background. You didn't want in the picture because you don't even know that person, and you are on the seaside with an ice. So you can using artificial intelligence to erase the person, but you want to let people know about that, right? So it's the minimum. So this is the attempt, but it's, of course, the standard is just one piece of a much more complex puzzle. You should have also basically all service providers and all product producers, manufacturers, to also adopt the standard. Now, how do you force people to do that? You cannot force people. We just talked about why is it that still people use PNG, even though there are better things. So it's a free world. People can say, I don't want to use it. So maybe there is a need for legislations that would say you need a means. And these things are happening. So if JPEG has brought in what it can do, which is a standard, But of course, there are other things that have to happen that range from creating awareness, letting people that it even exists, because if people don't know if it exists and they don't use it, right? So it's not going to help. So awareness building is very, very important.
Again.
Communication, but also you need maybe some legislations that would encourage, if not even force, companies and service providers to implement means. So it doesn't mean necessarily they should say implement JPEG trust, but they have to implement some means to do that. It's natural that because we believe in JPEG that we have really the top technology, best technology, because it was done really by the best brains and cream of the world in this topic. So we are really confident that this is the best technology. And then there is also another side that we can never know until this is not deployed, which is acceptability, social acceptability of these kind of things. So it is possible, nobody can deny that, maybe there will be drawbacks, maybe it's complex, maybe it's not easy to use enough, etc. That would force us to go back and maybe revisit, as we have done in the past. Maybe we cannot deploy this JPEG trust technology the same way JPEG 1 couldn't be deployed for every application that used imaging. Maybe JPEG trust cannot be used for every application. Maybe some application it will be successful, and some others we have to go back and find out why and come up with additional things. So this is the second, JPEG trust, JPEG AI, JPEG trust. We are now looking into the future, maybe in the horizon of 2026 or 2027. We are also working on a new format, but this format is a format that's coming from a new type of sensors called event sensors, and we call them JPEG XE. And this time, the sensors have been designed specifically for artificial intelligence. So very likely, a few years from now, the public will hear about this. These are new type of sensors that the same way the human eye, captures the information in a specific way and sends it to the brain to process. And the brain now, because of artificial intelligence, at least the current paradigm, is mimicking the human brain. The sensors are mimicking the human eye. I give you one example, just to give you one. There are many others that make these sensors particularly interesting. These sensors do not have the notion of frame. So a video, as you know, is made out of many still pictures. And we know that when you have more than 15 or 20 of these pictures that are similar next to each other with very small differences, your brain is tricked into thinking it's a motion. But the notion of frame does not exist in any living organism, that has vision capability, including humans. We don't have frames in our eyes. We don't capture still pictures. It's continuously going into our brain. Now, you could, if you believe in God, you say God designed you like that. If you are more realistic, you would say that's the natural evolution. If you are conspirator, you would say these are aliens that want to eat us later, that have designed us like that. So whatever the reason, the human visual system is not using the same principles that all the capture devices, all the cameras of the world today are operating. So you need a format if you want these cameras to be widespread. And this format is being standardized by JPEG committee. Again, it's a little bit, I would say, early to talk about the details of it, because the standard is foreseen for 2026, 2027. So we are 1-2 years away still from that time. But this is one of the consequences of the artificial intelligence impact on JPEG standards.
What will be the advantage of having a continuous flow rather than having these framed pictures that we have known so far with a cinema and including the video today?
Yeah, so that's a good question. I can give you, again, there are many, I'll give you a couple. You know that when you create a video, one of the things that, of course, happens in reality is that the pictures, the frames in the video are very, very similar. Now, if you want to code it, we talked about redundancy, your sensor has to 30 times per second, 50 times per second, 60 times per second, maybe sometimes hundreds of times per second, signal the value of the system, every pixel, by saying this pixel it has this value, it's the white part of the white wall on the back, but then you have to signal. So your sensor has to capture and send this information 60 times per second, 100 times per second. What does it mean? It means it's going to use a lot of energy for nothing. The sensors, if you do it continuously with events, you only signal it once. And you don't need to repeat that. That is a tremendous gain in terms of power consumption.
You talk about what is fixed. In other words, if you have a picture with moving objects, does it mean that whatever is fixed is to be defined once, doesn't have to be redefined?
That's correct. But even if your camera moves, there will be always parts that overlap. The value of the pixels don't change. For example, the white wall behind you, even if you move the camera, although it's not the same pixel, the value of the pixels don't change. Not everything changes in an image, right? So that's one of the. So you don't really on the sensor level, you don't need to do that.
Does it include, for instance, a walking person? In other words, if it's being recognized that the face has not moved much, but the legs have moved, in this case, just the legs will be redescribed?
No, it doesn't go that far. It's actually very low level, and this is exactly how our retina works, by the way. Our retina just sends signals to our brain every time the light that comes to the specific photoreceptor changes. So it's really very much, there is no semantic understanding by saying it's a wall, or it's the feet of a person or face of a person. You just say every sensor, in this case for these cameras, every pixel, you only fire it when the light that comes to it changes, exactly like the retina does it. And interestingly, that's how nature or aliens or God decided to design our vision system for our brain, which is a neural network. So we have resolved with artificial intelligence as it is defined today, we have only resolved half of the problem, the processing. But the capture of the information, if we really want to do it properly, we have to do it in a way that is more appropriate for the processing that follows. And that's what JPEG XE is going to bring. And JPEG XE is going to bring interoperability, a format that will allow you and I tomorrow to decide one day to buy a Sony camera that is event-based. And if I don't want, 3 years later, I move to another company that maybe sells it better for a better or a cheaper price. I want to give you one more because I promised 2 things in terms of JPEG XE. So one gain is that the power consumption is much less, which is not negligible. But the second gain is that currently the sensors, for example, who capture video, you have to define that every 50 or every 60 frame per second, you have to send the signal, right? So if some event happens in between two frames, you have to wait the next frame before deciding. Event-based cameras, they have, for the same complexity, a time resolution that is in the orders of tens of thousands of frames per second. So imagine you design a camera that can capture equivalent of 10,000 frames per second with the complexity of one that does 50 frames per second with the current paradigm. So this is also a very, very interesting feature, because not only, for example, in self-driving cars, you don't need to have very complex cameras, because 10,000 frames per second, we go into sub-millisecond resolution, which is very good. So we don't need to, for example, have special cameras of current generation that can do 1,000 frames per second, that are going to be much, much more expensive. So it will be much less expensive. But also it resolves other problems like blurring, right? So a lot of cameramen, they know that many of these cameras, even digital cameras, because of the limited number of frames, like 60 frames or 50 frames, when there is very, very quick motion, the sensors are not working properly, and you have fast-moving objects become blurry. The blurriness of fast-moving objects is to almost a perfect extent removed, and you can do amazing things. These are things that I told you by being the head of JPEG, I get the privileged access to, because the world that is going to happen in front of us 3-5 years from now is absolutely fascinating. There are new technologies that are being developed, and they will see their traces into new products. But these products won't be deployed if standards do not exist before. So it puts people like me in a very, very interesting situation, because we also get an exposure to the near, midterm, even future.
Artificial intelligence, of course, as we mentioned, allows fake information, allows to do almost anything with a picture. And of course, applications that will be able to denounce it or analyze it, will they really be able to chase the fake information? Are we going to observe what we can say about prisons? Let's say, as long as there are prisons, there will be always possibilities to escape. Now, isn't there a danger that IA or AI, artificial intelligence, will be able one day to deceive artificial intelligence?
Yeah, so of course, everything is possible. So it's difficult to say whether artificial intelligence is not going to be used to counter some measures like JPEG AI that are going to be put in place, hopefully, in order to identify. But let's not forget that at least JPEG Trust is designed in a way that the decision at the end of the day is in the hand of the human, not the artificial intelligence. Let me explain. It's probably wishful thinking to think that an algorithm would tell a human whether they have or they should not trust a content that they consume. There are several reasons for that. One of them is obviously that humans, in terms of governance, we should be always in charge. It would be a very, very bad idea to delegate important things like whether we should trust or not an information to machines. The machines can assist us and provide us with necessary means to make the decision, but we should not delegate that decision to humans. Second is legal reasons, right? You cannot take to jail a robot. Decisions, that's why, for example, although artificial intelligence is known, at least in some cases, for example, for analysis of X-rays, artificial intelligence today does better job than a doctor. So why we don't see doctors replaced by artificial intelligence? Because statistically they do a better job. The reason is legal. Because if there is misdiagnosis, and there is always misdiagnosis, who's going to get to jail? Who you going to sue? That there should be, because law, I think in German there is a saying is, law is for humans, right? Law is not for machines. Law is not for animals. You cannot put a dog in jail because the dog did something wrong. You take the owner of the dog to jail, or at least fine. So JPEG Trust basically does not give the decision whether you have or you have not trust. So typically, if you say picture, it gives you a lot of information to you so that you have the right context to decide based on your preference whether you want or you don't want to trust the content. Now, if you are, and I'm going to do that as half a joke, if you see a video or a picture that is coming from CNN journalist and you are more of a Republican, maybe you say, I don't trust them, they are fake news. And vice versa, if you are a Democrat-leaning American and it is on Fox News, you might say the same thing. Now, you don't know where the truth is, but the truth is in the hands of the end user. And then also these systems cannot be legally attacked because they do not make the decision. They do not say trust or do not trust, and then you trust, and then something bad happens, and then you can go after whoever put the information, trust this picture in it. They just give you what is called provenance information, when the content was created, what type of changes happened to the content. So maybe you took a picture with some camera, then it was in RAW, then you transcoded in JPEG, then you uploaded it to Facebook, but then before doing that, you resized it because the file was too large. Then somebody else downloaded it and then added some caption on the bottom of it, etc. So the trace, or the provenance, as it is called in the jargon, is put in a not falsifiable way in the file that always comes with it, and you can have profiles defined that will be based on maybe artificial intelligence or just a simple program that will read this information for you, and they say, based on your history or based on this and that, this picture seems to be coming from something you could maybe trust, but it gives you all the information, and at the end, you are the one who trusts. So basically, maybe it could be just like a label on the corner of the picture that would say, your profile says you can trust it, your profile says maybe you want to have a look at it, or your profile says you should not trust it. And then you just go on the hover over that logo or whatever, and it gives you information about why it is recommending that to you. But you have the final decision. So this is how JPEG Trust is done. Now, artificial intelligence can be used, of course, to trick this, but at the end, there will be always a human. So there is a human, and part of the trust and the metadata information that JPEG Trust can put is to say, oh yeah, there was another artificial intelligence system that did something to this picture, right? Now, to be complete, JPEG Trust not only brings you this kind of metadata information, about provenance, but also it gives you also information about the ownership and authorship. So it can at the same time be used also to track copyright information and things like that, whether you're authorized or not and under which condition to use a picture or not.
As well as intentions, which is very important.
And yes, and sometimes, by the way, you're absolutely right, sometimes, by the way, you could still mislead people by perfectly authentic content. You could take, pictures that are perfectly genuine of Kabul in Afghanistan and pretend this is what happened in Gaza in the Palestinian territories. So it's not only a question of what is the content, but also the context in which this was taken and used.
This is really a fascinating period, fascinating technology. Mr. Ebrahimi, it's absolutely fascinating to hear you, to follow all this evolution. And of course, the next step will be now to know more about you, to know what brought you to this world of technology with your origins. This is the next part of our interview.
Si vous souhaitez voir d'autres vidéoportraits, consultez le site Vitasummus qui met en ligne régulièrement nos interviews filmées réalisées à partir de 1978.